When you think about it, from the tallest skyscraper to the smartphone in your pocket, every single thing that's ever been made started its life as just a bunch of lines on a page. It's kind of like a secret language, a universal code that turns an idea into a real thing. And today, we're going to learn the basics of how to read it. Now, I know at first glance, this just looks like a crazy jumble of lines and numbers, right? But it's so much more than a picture. This is a complete set of instructions. It's like a perfect recipe for a machinist to create this exact physical object. Everything they need to know is right here. And that's the real puzzle, isn't it? I mean, we live in a 3D world, but this whole language is written on a flat 2D surface. So how in the world do engineers solve that problem? How do they communicate height, width, and depth with absolute clarity? Well, here's our game plan. We'll start with that basic challenge, showing 3D on a flat surface. Then we'll get into how engineers unfold an object to see all its sides. After that, I'll show you a really simple trick for creating a 3D view. And finally, we'll see how this all comes together to form, well, the blueprint for pretty much everything. All right, first up, the challenge of flatland. This is the core problem, right? How do you take a real-world 3D object and squash it down onto a 2D piece of paper or a screen without losing any of that critical information? And here's the most important thing to get. This is an art class. The goal isn't to make a pretty picture. It's all about perfect communication. An engineer needs to show an object's true shape and exact size with zero, and I mean zero ambiguity. Distortion is the enemy. So that brings us to the really clever solution: unfolding the object. See, if you can't show all the sides at once without it looking weird and distorted, what do? Well, you show each side one at a time perfectly. Just imagine you have a cardboard box, and you carefully cut it open to lay it completely flat. And this right here shows that idea perfectly. To really understand that 3D object, we're just looking at its individual faces, all laid out flat. Each one of these views gives us another piece of the puzzle. Now, this clever method, it actually has a name: orthographic projection. Sounds kind of fancy, right? But all it really is the standard way of showing an object from different angles. Usually the front, the top, and the side. Let's break that down. So we start by picking one main face. This becomes our anchor, what we call the front view. Just imagine you're standing directly in front of the object, and that's the only thing you can see. That's what you draw. Okay, next, you imagine you're floating directly above that same object, looking straight down on it. This gives you the top view. And from this angle, you're capturing a totally different set of dimensions. And this is where the genius of it all really clicks. The front view gives you the object's height and its width. The top view gives you its width and its depth. So by combining just those two flat views, boom, you now know all three dimensions of the object. You've got the complete recipe. Okay, but having the flat pieces is only half the battle. How do we actually rebuild that 3D image in our mind, or even on the page? Well, this is where a beautifully simple little trick comes into play. Believe it or not, the entire secret to drawing in 3D is hiding right here, in these simple angles. This one little geometric rule is the key that unlocks our ability to create a convincing 3D object from those flat plans. The technique is called isometric projection, and the rule is so simple it's almost funny. Any vertical lines on the object, you draw them vertically. Easy. But all the horizontal lines, the ones that give it that sense of depth, are drawn at a perfect 30-degree angle. That's it. That one rule creates the entire illusion of 3 dimensions. So now we have our tools. We've got the flat, orthographic views, and we have the isometric 30-degree trick. So let's put it all together and watch the magic happen. And here it is. This is where it all clicks. Over on the left, you've got those flat front and top views we talked about. On the right, you have the final isometric drawing. By taking the measurements from the plans and applying that 30-degree rule, we can build this perfect 3D representation. You can literally see how every line and every corner matches up. Now, this is great for showing the outside of an object, but what about the inside? Real parts have holes and grooves and all kinds of internal stuff. So how do you draw something you can't even see from the outside? Well, the answer is with a special kind of line. We use what are called hidden lines, and they're always shown as these dashed lines. Their whole job is to show us the invisible, to reveal all the important edges and features that are blocked from our view. Let's look at this one. The solid lines, they show the outside of the block. Simple enough. But Notice those dashed lines in the top and side views? They're telling us there's a V-shaped groove cut right through the block that's hidden from sight. Without those lines, you'd have no idea it's even there. It's how engineers make the invisible visible. So we figured out how to take an object apart into flat views and then put it back together in a 3D drawing, even showing the hidden parts. This isn't just some cool drawing exercise. This is literally the foundation of the entire modern world. And it really all comes down to this one simple thought. Everything is designed. Before anything can be built, the idea for it has to be communicated perfectly. And this visual language, this is the universal tongue of creation, understood by designers and engineers and makers all over the planet. You've just learned the fundamental grammar of the language used to build our world. So the next time you're putting together IKEA furniture or you see a blueprint, you won't just see a bunch of lines. You'll see the system, the front views, the top views, maybe even some hidden lines. So my question for you is, now that you know the secret, what else are you going to start to see?